All right, welcome back. So this is 2.4. We are writing polynomial functions. What's going to happen here is I'm going to give you solutions to a function. You're going to write the equation that created those solutions. So the idea is whatever the solution is, we're going to put it into its factored form, and then we're going to FOIL those factors together to create your polynomial expression. Recognizing that if I told you like x equals 7, that comes from the factor x minus 7. If I told you x equals -4, that comes from the factor x plus 4. The factor is always the opposite sign of the number in the problem. Now, if our solution's a fraction, like let's say 2/3, I don't want you to write x minus 2/3. That's not going to be the proper form for our answer because we don't want to create fractions in our problem. So the idea is recognizing that the denominator is going to be the coefficient of x, so this would be 3x, and then the 2, same as with the 7 and -4, the opposite sign. So it's a positive 2, so then it's minus 2. So if I have, like a -1/5, it would be 5x, because again, the denominator is the coefficient, opposite for the numerator, so then plus 1. All right, so that's the idea. What we'll be doing for each of these problems, writing them into its proper factor form, no fractions, and then we'll be FOILing everything together to create our answer. So we have 5, -4, and 2, so we're going to write this as x minus 5, x plus 4, and x minus 2. And in no particular order, we're going to go ahead and FOIL two expressions together, get an answer, and then FOIL with the remaining expression. I'm always going to write it left to right, so that's why I have 5 first, and the 4, then the 2. It's kind of up to you. So I'm going to FOIL the x minus 5 and x plus 4 first. So I'll get x squared plus 4x minus 5x minus 20, x minus 2, which then combine, please combine before you try FOILing again. Make your life so much easier. And then we're multiplying here. We got to remember every term on the left multiplies every term on the right. So I'm going to do x squared times x and x squared times -2. I'm going to do -x times x and -x times -2. And then I'm going to do -20 times x and -20 times -2. They're all going to multiply there. I'm going to create 6 terms in total. I'm going to get x cubed minus 2x squared minus x squared plus 2x minus 20x plus 40, which then combines everything to be x cubed minus 3x squared minus 18x plus 40 for that final answer. So that's the process we're going to go with. If there's more than 3 terms, we have 4 terms instead, for example, we're going to want to write that and FOIL the two binomials together to create 2 trinomials and FOIL those trinomials together. So I'm going to write this as 3x minus 2 and then 4x plus 1. Remember, the denominator is the coefficient of x. The numerator is the opposite sign afterwards. So that's x minus 2 and x plus 5. So FOILing the 3x minus 2 and 4x plus 1, I get 12x squared plus 3x minus 8x minus 2. FOILing the x minus 2 and x plus 5, we get x squared plus 5x minus 2x minus 10. Which then yields 12x squared minus 5x minus 2 to go with x squared plus 3x minus 10. And again, every single term on the left multiplies every single term on the right. So that 12x squared multiplies with x squared, 3x, and -10, giving us 12x to the 4th, 36x cubed, -10x squared. The -5x goes to the x squared, the 3x, and the -10, giving us a -5x cubed minus 15x squared plus 50x. And then finally, the -2 multiplies the x squared, the 3x, and the -10, giving us a -2x squared minus 6x plus 20. And the reason why I'm writing it like this right here is because it's going to allow me to group them a little bit better so I can see what the common terms are going to be. So I can recognize nothing combines with 12x to the 4th, so it stays where it is. I have 36 and a -5, making a positive 31x cubed. -10, -15, and -2 make a -27 x squared. Oh, wait, hold on. Sorry, I'm just realizing that this should be a 120, not a 10, because it's 12 times the -10, which makes it a -137 for that part. Sorry about that. negative 137x squared. And then the positive 50 and the negative 6 make a positive 44x, and then the plus 20 by itself at the end doesn't combine with anything. All right, so again, you don't have to write necessarily like that, but I kind of like writing it like that, especially when there's so many terms, so it's easier to see what groups together. When I fought obviously the two binomials, I didn't do that because it was a little bit easier to see the only two common terms. But it's useful, especially when doing a trinomial with another trinomial. All right, so that's your basics when you have integer or fraction solutions. Key, again, the directions are saying least degree integer coefficients. So that's how we know we can't write it as x minus 2/3. We have to write it as 3x minus 2. We don't want to have fractions in our answer there. Now, if we have imaginary or irrational solutions, we have to recognize there's always two imaginary numbers that go together and two irrational square root numbers that go together. So we have to include the conjugate expression. So if I have 4 minus 5i, the conjugate has to be 4 plus 5i. If I have negative 2 plus root 3, the conjugate's negative 2 minus root 3. Noticing the only thing that's different there is the middle sign. Is the only thing that's different from each of these problems. Writing them as the factors, again, like with the expressions, everything is the opposite. So a positive 4 would be minus 4, negative 5i would be plus 5i. And then positive 4 is negative 4, positive 5i is negative 5i. And then with the radicals, negative 2 is a plus 2, plus root 3 would make it negative root 3. And again, negative 2 is a plus, negative root 3 is a plus also. And then you FOIL with those expressions. There are other ways to go about doing it. There's a couple shortcuts, especially one that kind of recognizes you're creating a different to two squares scenario. And if you recognize stuff like that, great. So you can make your life a little bit easier. That's fine. We're just going to go through, you FOIL the whole expression, so you just combine like terms. So it's kind of very similar to what we've been doing for everything else. Now you'll notice I'm only going to give you one of the expressions. I'm not going to give you the conjugates. You have to recognize that on your own. So if I give you 3 minus 4i, you need 3 plus 4i. Conjugate expression. And then writing these, so we know we'll have x minus 5 as one term, and then we're going to have x minus 3 plus 4i, and then x minus 3 minus 4i. Make sure you always include the x there. If you're just writing 3 minus 4i, 3 plus 4i, that kind of thing, inside the parentheses, there's no x, you don't have a factor. That's like writing 5 and not writing x minus 5. So you have to include the x there. And every single time you're writing it, whether it's a single number or as part of a I or a radical expression, every number is the opposite sign when you write the factor. It was a positive 5, that's why it's x minus 5. It's a positive 3, that's why there's negative 3's, negative 4i, that's why it was a plus 4i, and then later plus 4i became a negative 4i. Also recognize 3 minus 4i is one answer. It's not two separate answers. Pay attention to where the comma is. The comma separates the answers. If there is no comma, there is no separation. So we're not doing 3 separate from 4i. They have to be put together. Now, when foiling this together, we again want to multiply all the i's together before we do anything else, because this is going to combine in a way that all the I terms are going to cancel out. So x times everything on the right, we'll get x squared minus 3x minus 4ix. Negative 3 now times everything on the right, giving us a negative 3x, positive 9, positive 12i. And then 4i multiplied with everything on the right, giving us a 4ix, a negative 12i, and a negative 16i squared. And you'll notice all the regular I terms are now going to cancel each other out. Negative 4ix and positive 4x are gone. 12i, negative 12i are gone. And then the last I is left is an I squared. Well, we have to remember that if I is defined as the square root of negative 1, that means I squared is equal to negative 1. So I really have negative 16 times negative 1, which means this is really a plus 16. And what's supposed to happen, and if it doesn't, you screwed up somewhere, is you combine all your remaining terms, and you're supposed to create a quadratic trinomial that does not have an I term left over. Okay, so if you had 3 minus 4i, so you had a trinomial with another trinomial, you're going to create a quadratic trinomial on the ends. If it was a binomial, let's say it was just x plus 4i, x minus 4i, you're going to create a binomial quadratic. It'll still be a quadratic, but it'll be a binomial instead. There won't be a regular middle x term. And then from here, again, same thing. We're going to go ahead and FOIL this. X times everything on the right, giving us x cubed, negative 6x squared plus 25x, and negative 5 times x squared times negative 6x times a positive 25 we get x cubed minus 11x squared plus 55x minus 125. And there's our final answer. All right, so that's the process with I. With a radical, it's the same idea. So if we have negative 3 plus 2 root 7, it's negative 3 minus 2 root 7 for our missing term. Writing our factors, we have x minus 5 and x plus 4. And then again, it's always the opposite sign, so it's going to be x plus 3 minus 2 root 7 and x plus 3 plus 2 root 7. Always the opposite expression, opposite numbers. We go ahead and FOIL the x minus 5 and x plus 4 together. And then we go ahead and FOIL the radical expression together, where again, the radicals are going to cancel out in the end. If they don't, something went wrong somewhere. And we'll get x squared plus 3x plus 2 root 7x for doing x times all of that on the right, plus 3x plus 9 plus 6 root 7 for the 3 times everything on the right, negative 2 root 7, negative 6 root 7, and then lastly, doing that negative 2 root 7 times a positive 2 root 7, well, if you're multiplying two radicals together, their outside numbers multiply. 2 times negative 2 is negative 4. The insides multiply, and if it's the same radical, they cancel each other, leaving just the inside. Negative 4 times 7 is negative 28. So this right here is really a negative 28. Like with all the i's in the previous problem, the radicals are now going to all cancel. 2 root 7x, negative 2 root 7x. That should be an x right there. Positive 6 root 7, negative 6 root 7. So both of them combine down to be a quadratic trinomial, x squared minus 20 for the first, x squared plus 6x, and then minus 19 for the other one. All right, so you just need to make sure you're careful with your combining right there and then multiplying the 2 root 7s here, because all the other radicals are going to cancel. So the key really is going to be what's happening when multiplying the 2 root 7 times the 2 root 7 and getting negative 4 times 7, which is the negative 28 we want. And then our last FOIL, we'll get x squared times everything, giving us x to the 4th plus 6x cubed minus 19x squared. And then negative x times everything is negative x cubed, negative 6x squared, positive 19x. And then 20 times everything gives us a negative 20x squared, a negative 120x, and then a positive 380. So our final answer would be x to the 4th plus 5x cubed for the 6 plus negative 1. Negative 19, negative 6, and negative 20, making negative 45x squared. 19x and negative 120x make a negative 101x, and then plus 380 at the ends. So that's our writing of the polynomial expressions given the solutions of the polynomial. Be careful with your foiling, be careful with your setup. Don't forget the x's, don't forget to write the conjugates, opposite sign. There's a lot of different areas you can mess up, so you have to be careful each step of the way. Again, some ways you can kind of check this a little bit, depending upon the problem is if you were to graph, like if I were to graph this final result right here, I would find that there are 4 x-intercepts at 5, negative 4, and then whatever the decimal value for those radicals are, I can see if that matches up. With the imaginary, you really can't get that, but you can still check to make sure, like here, if I were to graph this thing, I should still see us crossing at 5, so that I can at least verify that part is right, and I didn't, screw anything else up there. But you just have to make sure you're just careful with your setups. All right, only one more topic in Unit 2. It's pretty much actually the reverse of what we just did here. Here I gave you solutions, you had to write the equation. 2.5, our last topic, I'm going to give you the equation. You got to write for me the solutions. So I'll see you next time for that one.